All right, the final example. The water in the Flint River flows at 5 kilometers per hour. A speedboat can go 15 kilometers upstream at the same time it takes to go 25 kilometers downstream. Again, upstream and downstream are in the problem, making it this kind of a problem. How fast can the boat go in still water? So the question they're asking us is the still water speed of the boat, which is one of the two things we're looking for to begin with. So we don't know what that is. So I'm going to put B equals question mark. What's C? 5. Very good. The water flows at 5 kilometers per hour. And I might even put, kph up here just to remind myself that's the type of unit we're dealing with for this. If rate's in kilometers per hour, that means time is going to be in hours and distance is going to be in kilometers. All right. So I don't know what B equals. I do know what C equals. All right. And so we worry about rate first. And again, it's always B plus C, B minus C. Upstream is B minus C. I don't know what B is. I subtract 5 because that's what C equals. And then it's going to be B plus C, B plus 5 because, again, I don't know what B is, but I know C is equal to 5. So always make this your priority so it's really easy to make the rates what they should be. Again, using a variable to represent things we don't know, using actual specific numerical values for things we do know, and always doing the speed of the boat plus and minus the speed of the current for each of these. Now, once again, if we take a look at stuff, it says 15 kilometers upstream, so I know exact distance upstream, and 25 kilometers downstream, I know exact distance downstream. I can't remember any of these problems where they don't tell you both distances. They always leave out something about rate or something about time or just everything about rate, nothing about time. But they always leave two things unknown. It says in the same time. Once again, it's a situation. I don't know what the times are, but they are equal to each other. So it's pretty much similar to the first problem. Difference is this first problem I didn't know the current. This time I don't know the speed of the boat. All right, but and all they're asking for is how fast can the boat go in still water. So we're looking for B. Once again, I get a binomial times a monomial. In both cases, it's always rate times time equals distance. So if I do rate times time, I'm going to get BT minus 5T is equal to 15. And then this one's going to be BT plus 5T is equal to 25. Once again, elimination is legal on this problem. And the current setup will get rid of 5t quite nicely, but it won't get rid of the uglier term, right? So again, keep that in mind. That always make a plan when you're doing elimination to get rid of the best thing to get rid of. In this case, bt is better to get rid of than t. So I'm going to change the signs on the top. So negative bt, positive 5t, negative 15. If I add the equations together now, negative and positive bt cancel. A positive 5t and positive 5t make a positive 10t. Negative 15 to 25 make a positive 10. If 10t is equal to 10, therefore t equals 1. They don't ask me for the time, but finding the time helps me find what they're asking me for. So a lot of times you'll have to do this in algebra where I don't need to, I'm not required to find this thing, but finding that thing makes what I'm looking for easier. And then I go back, I'm going to go back to the bottom one. Anytime I go everything positive, that's where I usually go to. I like that better. All the t's equal 1, so b times 1 plus 5 times 1 equals 25. Took this bottom equation here. Both of these t's became 1s. That simplifies to b plus 5 equals 25. And 20 plus 5, so b is equal to 20. And the unit of speed is kilometers per hour, so I'm going to put kph next to it. All right. That's basically what a boat in the river problem is. That's how you handle it. Again, the recipe is right there on that blue sheet. Follow along. And if anybody's watching this video tonight that doesn't have a blue sheet, then you can always pause the screen on the first video to see what was on the blue sheet.